Okay, this is page 1 of the finals packet for quadratics and imaginaries. Question 1 on the first page is find the solution to this quadratic equation. If you try to factor this, that's not going to work. Completing the square is going to be too much work. So we use the quadratic formula, and you plug into the formula, which you should know by now, and that's what it looks like in the numerator, and that's the denominator. In the numerator, though, you're going to get a negative number in the radical, and that's going to mean we do have imaginary numbers. So that next line, got to break it up into square root of -1 times square root of 4. My students, 2 in the bottom. And the numerator is going to be square root of, well, square root of -1 is I, square root of 4 is a positive -2. And
talking to
my students,
I can't see it.
you want to see it? Look, see? All the three numbers there are divisible by 2. And you can only divide it if they are all divisible. In this case, they can't. To the iPad. Divided by 2, because they're all divisible by 2, becomes 1 plus or minus -1 plus or minus 1i over 1.
What's my water?
Use upstairs. And then you don't need the one in the denominator really, so you can leave it like that. You notice that's our answer, but in the multiple choice answers, they write it 2 times separately like that. So you got to be able to recognize that that's the same answer. Now going on the second question. People are tricked up by this because it doesn't look like everything else, so what we need to do is make it look like everything else that we're used to. I'm going to multiply by x squared, so there will be no more fractions. And you, step 1, distribute x squared to the 1. Distribute it to the 1 over x squared. Oops, I missed my square. Let me get that in there. Whoops. Okay, that's fine. Next, oh, it's there. Next, multiply it to the x squared to the 3 over x. So you're changing the look of it, but not the value. Okay, next line, x squared times 1 is x squared. The x squared times the 1 over x squared will cancel to be 1, and the x squared times 3 over x, one of the x's cancel, and you'll be left with 3x. Now you move the 3x over by subtracting it, and boom, you got a normal standard form of quadratic equation. Still can't factor that, so you use quadratic formula, and I'll let you take that one from there. That's just like the first question. Yay. And now the one that we haven't done too much of, so we'll probably want to pay close attention to this one, is solve this by completing the square. So we have this equation here. Whoops, I probably should have. Well, that's right, like that. That's your equation that they give you. And now to complete the square, we take the b term, or the -8, and we're going to make that a complete square number. A perfect square number, watch. So take the -8, cut it in half, and square it. But to balance that, you have to do that to the other side as well. So the purple are new numbers, so they have to be balanced. Now when you take -8, cut it in half, and square it, you get 16, which is a perfect square. That's why it's called completing square. You create perfect squares. Now we combine the 9 and 16 to get 25. Move the -25 over. Why? So we can get it to equal 0. Now we have this new quadratic, not new quadratic, well, it's new in look, but it's the same value. And we can factor this, yes. So no quadratic formula or completing square. Well, we were completing square. So that one is just x minus 9 times x plus 1. And x equals 9, or x equals -1. But in doing this, I totally didn't read the question carefully, like I've been telling you all year long. The question doesn't say to solve it. The question just says find the number to add to both sides. Bam, the 16. So that's the answer to this question. Woohoo. Okay, last one. Translate this quadratic function to that quadratic function, except they are in not standard form anymore, but vertex form. So to find out how they move, let's take one place. Take the vertex of both of them. So -3 comma -2 for the first one. So this is a reminder of how to find the vertex. And the second one is +2 comma +2. So how that moves is just take those two vertices, bam, bam, and see how they moved. Well, the original one down here, that's the OG, we're going to find how it gets, whoops, make sure right there. How does it get to the new? Well, we have to go up 4 and over 5. So the answer there, I think, what given to you is move up 4 and 5 to the right. So that's how we find out how the first equation translates over to the second equation. Alright, so that's the answer to the first set of questions, the first page. Over the next few days, I'll do the other 3. Okay? Alright, thank you for working hard over the break. It'll pay off. Okay, signing out.